start this recording. All right. Hope you guys had a nice break. Yesterday, a surprise break. I'm gonna get so much done. It's gonna be crazy. I didn't get any of it done. Anyways, that's all right. We will survive still. All right. Let's see here. I just wanted to point out, let's just focus on this week here. Whee! That's good enough. Just as a heads up here, and maybe I'll just crop this down a little bit. It's not wanting to do what I want it to do. Oh, and let's crop all this. We don't need that. Okay. What was it I wanted to say? Oh yeah. All right. So what I want to do is I want to post instructions for the quiz before next day, and then we'll talk about the quiz next day. But in terms of kind of a general guide, it's going to be on material from assignment 2, assignment 3, and assignment 4. That first assignment really had nothing to do with course material. That was just for me to learn a little bit about you. Okay, so here, these 3 assignments are going to be quiz number 1 material. Okay, as a heads up, the assignment 3 and assignment 4, they're due next week. Our quiz is on Friday though, right? What am I making you do? Oh my gosh. Am I making you do an assignment before it's due? I make it the due date afterwards so that then, you know, if you wanted to go back and you wanted to work on those assignments, you can, but really you should be done those assignments before you do the quiz because the quiz is on that material. And isn't that so nice of me? No, that you can cross something off the list before it's due. What a great feeling. So this assignment 3 is going to be on material that we wrap up today. All right, so after today, you'll be able to do the assignment 3. It's quite big because we spent a lot of time talking about, you know, the mean, the median, the standard deviation, the interquartile range, which we haven't talked about yet, but we will today. It's exactly what it sounds like, right? 5 number summaries, right? That kind of fun stuff. Okay, and so after today, you'll be able to do that assignment 3. And then assignment 4 is just itty bitty. And you'll be able to do it after Thursday's class. You'll probably be able to do it today if you wanted to, right? By kind of skimming the textbook and just kind of using common sense. I think you can probably do it already. Okay. But I posted it so you can try it, but really we're not going to do this material until Thursday. So let me write down what I had here. Oh yeah, I think do the assignments to prepare for the quiz. Quiz 1, we're basically just working out all the kinks. It's not a hard quiz. I would say if the assignments are feeling good and those questions make sense, then the quiz is going to be totally fine. Okay. And so, but it's really kind of working out the setup, right? You have to bring your laptop, which Again, I'll post instructions for you to read before next class, and then we'll talk about it more. But you're going to be doing your questions on your laptop in here during the quiz. Okay. And then any written work that you want to give me, just in case you need me to check something, then you'll hand it in to me after the quiz, right? So it's an online quiz, but we're doing it here so that obviously I can watch you, but also help you if you have questions, right? I do want to say the quizzes are 10% each, right? That's not a lot, so but it's something. It's all something. If you have to miss the quiz for whatever reason, then I just shift the weight of that quiz to the final exam. Well, hold up. Why wouldn't I just skip a quiz if I know I'm not going to do very well, right? Things have come up and I can't prepare, blah, blah, blah. Same deal, okay? So if your final exam ends up being better than a quiz, I'll shift the weight of that quiz to the final exam. What? That doesn't, no, it does make sense because you've shown me that you can improve. And that's all I care about, right? And so I want you all to have good grades, but I can't just give you good grades, right? You have to show me that you've improved. And so if your final exam is better, then I'll pretend that you didn't write this quiz or the next quiz or whichever one, right? And then, so I guess what I'm trying to say is I want you to write the quizzes. So even if you feel like I'm not prepared, this one, it's going to be really, really bad. I don't want to do that, right? I encourage you to write the quiz anyways, because from my perspective, right, when I'm trying to get you the highest grade that I can, it helps if I have something to work with, right? So if you've written all the quizzes, even if they're not that good, if there's something for me to kind of work with, right, then I can get you there. But if you come at the end of the term and you tell me, oh, well, I wrote quiz 2 and I did half of my assignments. Well, what am I supposed to do with that? Right. And so, so just get grades in. They don't have to be good, but just kind of get me everything that you can for me to work with. Okay. So that's going to be the rule for the quizzes, right? If you miss a quiz or if you do poorly on a quiz, meaning you do better on the final exam, I'll just pretend that you didn't write it and then put it on the final. Okay. Hopefully that makes sense. Okay, so in terms of practice for the quiz, these 3 assignments, so assignment 2, assignment 3, and assignment 4, because the first assignment was just for fun for me, maybe not for you. It's fun for me. I haven't finished reading through all of them, so it was one of those things. Oh yeah, I'm definitely going to do that this weekend. No, I went home and played with my dog instead. It happens. So, okay. Any questions about that? So, material for the quiz. All right, so we're going to finish section 2.1. It's a big chunk of this chapter, right? Is numerical data. What can we do with it? What should we be doing with it, right? And I think where we left off, or maybe let's do some quick review here. This nagging feeling that I forgot to mention something, but that's okay. So as some quick review, right, we said that if we have normally distributed data, so normal data versus just kind of non-normal is where we'll draw the line. In terms of our center and our spread, our numerical measures will depend on the shape, right? That's where we kind of, we almost got there, right? But it's nice to have a little summary here. We can talk about the mean, the standard deviation. And then I showed you how to find the median. And then we said the interquartile range is how we're going to measure the spread for non-normal data, and we abbreviate that IQR. And that's where I want to pick up, right? So I showed you how to do find the median by hand, which is silly, right? And I'll show you some R output just to show you that it's slightly different because it uses a fancier technique, a weighting technique. But in general, it's good to have an idea of what it's doing, especially for the median and the interquartile range, because at its core, you have to sort the data first, right? But sorting can take a long time, kind of computationally expensive if you're dealing with a massive, massive data set. So it's just something to keep in mind that, okay, well, here, if I'm finding these values, the median and the IQR, I would first have to sort the data. And maybe I don't want to ask my computer to do that because it could take a long time, right? Maybe I don't find value in that kind of thing. So anyway, so we used my my patent pending, not really, boop, boop, boop method. Hey, did I start this recording or what? Oh my gosh. I feel like I have that little panicky moment every day. And I probably do. I wake up from nightmares. It's a recording. So let's bring in from last day where we ended off. We also looked at what if we remove a data point, right? What if the structure of the data is a little bit different, then I'm landing on values. But let's go to that original. It was data on the GDP of different countries. Can be anything, but that's the example that I had. Okay. So we found the median first, and then we were able to find the quartiles. And then I can find the interquartile range, which is exactly what it sounds like, right? Inter means between, and the range between the quartiles is the interquartile range. So that's the distance between Q1 and Q3. So I guess, I can't remember if I introduced it, but let's say that's the end of the review. Then the interquartile range, we're going to calculate by Q3 minus Q1. Only because I don't want to have to deal with negative values, right? It's a distance between the quartiles, so it should be positive. Okay. So this is the measure of spread. So this is a common measure of spread for non-normal data. Okay, so the interquartile range, of course, in this case, would be 5.8 minus 4.0, 1.8. That doesn't tell us anything right now, but that's how we would find it, right? Oops. So in our case, it's 5.8 minus 4.0, which is 1.8. We're going to use that later. So just kind of sit on it for a little bit. Let's see. My nose was so runny this morning. I was so embarrassed, but it is only because I stopped taking my allergy pills. At first, I'm going to school. I'm like, I don't know. This is crazy. No, it's just my allergy pills. But do you have to stop taking them at some point? Do you just take them all year? I don't know how it works. But I was like, enough's enough. At some point, you have to stop taking them. Take them in the summer. That's fine. That's normal, I think. Anyways, that's my personal issue that we all need to be aware of. So with the median, the quartiles, we usually call this the 5-number summary, okay? And it's a way of summarizing the data. And so we can summarize numerical data. We can summarize numerical data using a 5-number summary. And in this order or the reverse, but they have to be sorted, right? To find the quartiles and the median and all that fun stuff, we had to sort our values, right? And so the 5-number summary has to be sorted, and it goes minimum Q1, median Q3, and then the maximum. In our case, right? Well, once we've sorted, then the minimum and the maximum are kind of easy wins, right? So I like to start there, just kind of get 2 of them out of the way. Let's see here. So I can just look at my data. Yeah.
Is it not upper whisker, lower whisker?
No, but we are going to talk about the whiskers today.
Okay.
Yeah. And because they're not data points, but I'll get that.
Okay,
Yeah. But good. So the minimum was 2.9 in our data set, right? 9.4 was the maximum. If these were 1 mark each, you'd be laughing, right? And they usually are, right? Quiz 1 stuff, 1 mark each. Okay, if you've just sorted the data, you got 2 out of 5 already. That's feeling pretty good. Okay, and then usually I start with the median. Hey, chatty, so chatty over there. Usually I start with the median, right? 4.65. Q1 was 4.0 and Q3 was 5.8. So that's a 5-number summary. We can use the 5-number summary to figure out the distribution of the data. Wait, I thought the distribution was the shape of the data. It is, right? It's not very helpful to know that 25% of your data falls between 2.9 and 4. That's hard for our brains to do, right? And then another 25% between 4 and 4.65, right? You can see our brains aren't wired this way, right? So one way that we can visualize this 5-number summary is through a box plot. It's a little bit more than just the 5-number summary, but it's built off of the 5-number summary. Okay. Good. There. And just as a reminder, right, Q1 has 25% of the data below it, 75% above. The median is the central value, of course, but we kind of beat that horse last day. And then similarly, the Q3 has 75% of data below it and 25% above. The most common mistake I see is people forgetting to sort. But Emily, how can that be? You say it all the time. I know that. So what I want is I want the layout of the 5-number summary to kind of serve as a reminder that, oh, right, I need to sort this, right? And so use this as a reminder, or use these as a reminder to sort the data. Before finding the quartiles. Before finding the quartiles. The median is also a quartile. It's the second quartile, right? We usually don't call it that. So I use that as a little kind of reminder. I need to sort this. And I've done it too, right? Trying to do things quickly, forget to sort it. Okay. So what we said was we use a box plot, so something called a box plot, to visualize the 5-number summary. So we use a box plot to visualize. I'll specify numerical data, has to be numerical. It's an alternative to a histogram, right? Usually we go with a histogram, it makes it easier to see, but there's pros and cons that I'll outline. So we use a box plot to visualize numerical data, and I'll put in brackets an alternative to a histogram, because sometimes that's confusing, right? I thought we used a histogram. Well, it's an alternative, okay? And it relies on the 5-number summary. Relies on the 5-number summary. Yeah. So at this point, I want to point you towards these numerical summaries that I posted. So I posted the RMD file, okay, which I'll show you. It comes up kind of weird, but you can usually you can download it or copy and paste it. The PDF might be nicer to look at, right? But if I click the RMD file, it just shows up like this. But if you just Control, copy, and then bring it into either your RStudio, you start a new RMD file, or in RStudio Cloud, which I have here, but it's gone to sleep. Resume. Okay. You can copy and paste it, and you can have that code, or if you want to type it out, because it's nice to do something kind of mindless sometimes, that's fine too. Okay, so I want to pretend I haven't done anything. The blurb, so remember, and maybe I'll zoom in here. In your RMD file, for your first assignment, when you wrote your bios, you really only wrote in the white section, right? Which I said was kind of the equivalent of Word, right? If you're writing a document, you write it in Word. And so this is where the text goes. And then we just completely avoided the gray areas. We saw them, we deleted them, right? But those are where the R code chunks go. So, and the gray areas are essentially the Excel component, right? Or R. And the anatomy of it is a tick, 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 curly brackets, and then R, because it needs to know what language you're using here. You can use other languages, Python. Can't remember what the other ones are. If I want to insert a new R code chunk, I hit this +C, so a new command chunk. R is obviously the kind of the go-to, but you could do Bash or D3. I don't know what those are. Python, RCPP, SQL, or Stan. Those are all options, but for us, let's focus on one, shall we? So you have to tell it that you're giving it R code. And I'm really only showing you this so that you could check your answers if you wanted to, right, using R. So how do you give it that data? So this is the data, it's sorted already. And how we kind of feed it into our, I don't know why I put a space here, but I did. I think to emphasize that there's a lowercase c and then in brackets, and then all the items are separated by commas. Okay. The C is for concatenate, which means stick together. Okay. And I assign it to something called GDP. You can call it whatever you want, but GDP seemed like a good choice, right? And so what I could do is pretend I didn't do this morning and clean up here, there. Okay. And looks like this, there. Now it looks like I didn't do it already this morning, all clean. Okay, and so if I want to run this code chunk, if I'm on a computer, there's shortcuts, but if you want to just hit play here, right, then it transfers it. And what happens if I hit it, I hit that play button, it bounces down here. So this is where we store our code, and this is where we run our code. Okay. And so this is the console, this is the actual brain, right? So this is where R is. And then GDP shows up here just as a reminder of all the things that it knows, right? So I know GDP and it looks like this, and you can expand it if you want to, right? But that's where it shows up all the things that you've already run. Okay. So if you had to enter different data, right, what would you do? Well, you would probably not have it named GDP because it's not GDP probably, but just anything without spaces is fine, right? And then within the C brackets, just separate by commas and then you're good. So, too loud back there.
I know.
Or maybe it's loud up here.
I just want to hear your. That's it.
Oh, thank you.
Streamline.
Yeah. So if you think about mathematical functions, right, f of x, right, what does that look like? Well, we have an f and then we have a bracket x, and these functions are the same, right? So if I do hist of GDP, what do we think that's going to do? It's going to make a histogram of the GDP data, right? And so there are built-in functions and tons of them, right? And if we run this code, oh, and I also had, you can go outside and do it. We usually write comments in our code, right? Kind of notes to self. Usually my comments are something like, this doesn't work, come back to this later, save this for another time. They're all like that, okay? And so if you want to write a comment that you don't want to run as part of your code, you use a hashtag or a pound sign, or I just learned on the radio this morning, it's called an octothorpe, I think. I haven't confirmed it, but I think it's called an octothorpe. It's like trivia on the radio as I'm driving here. Yeah, I use those. So anyways, so you can write little comments in your code. And so here I've done an example. But if I run this hist of GDP, it generates this histogram of the GDP data, and I'm zoomed in, so there. And I've already taken a screenshot of this and saved it, so I'll just reuse that, but that's where it's going to come from. Okay, so here we can see the distribution, right? And so it's skewed, but even though it's skewed, I can still calculate things like the mean of the GDP, right? Which is exactly mean of GDP And the standard deviation of the GDP, we use SD of GDP. What I want you to remember when you're using R is, and I'm just gonna delete this block here if I can see, because I want to generate this one together. Not much surprise if you've already seen it, but whatever. When you're writing R code, you don't have to remember all these commands or all these functions. That's crazy, right? And so a lot of your job is going to be to just know that it exists, right? Know that you can find this if you need it, right? How do I find the mean in R? How do I find the standard deviation in R, right? Or if you have an idea of what the function might be called, like box plot, for example, right? We said a box plot is a way of visualizing the 5-number summary. Well, what if I want to make a box plot? Okay, I don't know, but here we go. So I'm going to insert a new R code chunk. Dink. And usually if it's me, I just kind of start typing. Well, it's a box plot, so why don't I just try box? Oh, phew. And then it comes up with some options. And I want to boop, boop, boop. Let's see here. There. Right. So if you have some idea, you can usually get there, right? And it kind of prompts you along the way. But let's just use the basic box plot command. Of course, there's fancier ways, but we're just getting an idea of things here. So if I hit box plot, then it's going to say, well, I need some data to make a box plot of. Luckily, we have that data. It's called GDP. You could just be inserting that list of numbers, right? So lowercase c wrapped up in brackets separated by commas. That's how you would use and reference that data set. But if you find that you're just reusing something long like that over and over again, you should probably store it to make it easier for yourself, like we've done here. Okay. So you want to keep your eye on the autocorrect here. It's like, do you mean godparents? No, I mean GDP. So if I ask it for a box plot, then I can just hit play here. And there's other things I can add in that, but this is all it needs. Come on. Think. It doesn't want to listen. Oh boy. Hello? There. Hey, what a surprise. There's a box in the box plot. Okay. So again, I've screenshot this as well. Okay. And the last thing I want to show you is, I'll let you read this on your own, but is the summary command. The summary command is the 5-number summary. It also throws in the mean. We'll talk about why. But let's just have a look at the summary command as well. Come on, there. Notice how it's slightly different. So the minimum and the maximum are the same, of course, that we expect them to be the same, otherwise we did it wrong. Turns out the median is also the same as what we found, but the first quartile, we had 4.0, and here it turns out it's 4.050. And the third quartile, we had 5.8, but it's got 5.6. And the reason for that is it uses that fancier kind of weighting to find the quartiles. Okay. I think it looks at, kind of where the points are kind of clustered and stuff like that. So it does fancy stuff, which doesn't really make sense for small data sets. So, but that's what it does. So I've got a screenshot of that as well that we'll be referring to. But yeah, so you can use this just to play around and just kind of get comfortable. We're not going to use R for any testing situations, right? It's just good for life to know that, okay, I could probably do this in R as well. Or not, I don't know. Okay, so let's throw in that box plot that we had here. So here is a box plot. Maybe I'll put it over here. Sometimes we get a little crazy and we show it like this. Ah. Now, how do I undo that? I think there. Undo button. That's good. All right. So if we start in the middle here, this thick line in the middle of the box is the median. Okay, so let's start there and just kind of break down the anatomy of the box plot, I guess. Median. So the median is always in the center. You could put the mean on there, but usually the default is no. The box itself, forget I have the pointer in here. The box itself are the quartiles. And because we've got this increasing range here, then of course, the one on the bottom is Q1 and the one on the top is Q3. Okay, so here, this is Q1 and this is Q3. Which makes this distance, right, the width of the box is the interquartile range. So this distance here, wait, I went too far, is the interquartile range. Okay. We know that the minimum is 2.9 in this data set, right? And it looks like this whisker, it's called, cute, right? So these are called whiskers, and it looks like this whisker goes right down to 2.9, right? Or the minimum. But what happens up top? So this is a whisker, and this is also a whisker. But we also see a little dot up here, and pretty intuitive, right? It looks like an outlier, it is, right? But how do we determine if we have an outlier or not? That's what we want to kind of dissect today, okay? But these whiskers, let's be proper, they extend to the most extreme values in our data set within some upper and lower bounds. Okay, we also call those bounds fences. So same thing, but the whiskers extend to the most extreme. I have to be kind of generic about it, the most extreme, because there are extremes on both ends, right? On the bottom and on the top. So the whiskers extend to the most extreme data points within the upper and lower bounds or fences, they're called. Any values beyond these bounds or fences are considered outliers. So then here, right, any values, and maybe I'll Oh, I didn't think my colors through here. Oh boy. I've used them all. That's okay, I'll use green again. Any values beyond the upper or lower fences are considered outliers. Which means that we have to know how to find these upper and lower fences, right? And there were lots of different ways that were kind of explored in the past, right? It's pretty well set in stone now, but the most common way to do it is to take that interquartile range. And what we do is we multiply by 1.5, just make it a little bit bigger. And then we say, okay, I'm allowed to go 1.5 times the interquartile range above Q3. Anything beyond that value is going to be an outlier. And same thing, but on the lower end, I can go that far below Q1, right? So notice we have to move out from Q1 and Q3. And so that's the same as if I go down from Q1, I'm subtracting from Q1, but if I go up from Q3, I'm adding to Q3, right? So I've got two different formulas. Don't want to mix those up. Okay. Let's see here. To identify outliers, we use the 1.5 IQR rule. Oops. Which I guess I should say is also called the empirical rule. I'll never call it that. I just call it the 1.5 IQR rule, but it is called the empirical rule. Or did I just lie to you? Would I lie to you? I think I'm lying. I take it all back. I think that's a 68, 95, 99.7 rule. Now that I think about it. Yeah, forget I said it. It's just called the 1.5 IQR rule. We could use 1.75, we could use 2, we could use 1, right? But Tukey is kind of the guy who came up with all this stuff, box plots and things like that. And so we use his, which he landed on 1.5 was a good trade-off between finding outliers and including too many outliers in our data and not considering them outliers, right? Because that's what we're trying to do, right? We're trying to find some cutoff where we can say that, okay, these guys are outliers and these guys are not, right? So there had to be a trade-off. Okay, so we use the 1.5 IQR rule. They gave up. There's no one there. That was quick. I think. So the 1.5 IQR rule, we use it to find these upper and lower bounds. Okay. Let's remember that the interquartile range, oops, is just Q3 minus Q1. And we find the upper and lower for a little bit longer. I'll say bounds / fences, but you can use them interchangeably. / fences by, I'm going to start with the lower bound, which we said, okay, I'm allowed to move down 1.5 times the interquartile range from Q1, right? So it's going to be Q1 minus 1.5 times the interquartile range. Yeah. Whereas the upper bound now I can move up from Q3 plus 1.5 times the interquartile range. I'm going to highlight those differences because they always throw people for a loop. Yeah. A quick note that these are just bounds, right? We're not adding them into the data set, right? They're just, if you pass this point, you are an outlier, right? And so remember, these are not data points. So they are not included in the box plot, right? Not explicitly. We use them to find those whiskers, right? But remember, these are not data points. So they are not included in the box plot. So if we think about, and maybe it is the last thing I pasted, let's see here. Haha. I'll clean this up a little bit maybe, or maybe it's just fine. Yeah. So using this, we also found that the interquartile range earlier, we found that it was 1.3, and maybe I should say that this is what I'm doing. From our example last day, kind of unfair because I can cheat and just copy and paste it, but the interquartile range we said was 5.8 minus 4.0, which was 1.8. Since I'm about to take 1.5 times the IQR, usually I'll multiply it by 1.5 here already, right? Or I'll show it as part of one calculation. I always want you to show everything kind of properly. Okay. But if the question is, are there outliers? Are there any outliers in the GDP data? That's when we have to use the 1.5 IQR rule, right? And then that's going to feed into the box plot. Right, so really what I'm saying here is use the 1.5 IQR rule. Yeah. So our lower bound we said was Q1, and even just intuitively, right? We know, okay, I have to move down and up. So Q1 minus 1.5 times the interquartile range. Q1 was 4 minus 1.5 times 1.8, which I have is 2.7. Hopefully that's right. I did not check it. 4.0 minus 2.7 puts me at 1.3. Same thing, the upper bound or fence. Now, right, in my mind, for the upper bound, I have to go up from Q3, right? So Q3 plus 1.5 times the interquartile range. Wait. Q3 was 5.8 plus, and I've already done 1.5 times 1.8, so I'm just going to put in 2.7, which puts me at 8.5. So what we're going to do with these numbers, the upper and the lower bound, is I'm going to paste this one more time. But now I'm going to take this lower bound, and what I do, since this is all sorted already, I'm going to put where 1.3 would be, not adding it to the data, right? But where it would be, right? So here is where 1.3 would be. So now it's easy for me to see that, okay, well, the most extreme value within the lower bound is 2.9, which is my minimum, right? So essentially, if your minimum and your maximum are contained in the bounds, there are no outliers, right? So there are no outliers on the lower end. Let's try the upper end. Oh, it's almost by design, right? So 8.5 between 7.3 and 9.4, right? And so if I do this here, this is where 8.5 would go, somewhere there, right? So now I can see that 9.4 would be the outlier, right? So I don't just know that there is an outlier or how many outliers, but I also know what it is, right? It's 9.4. So let's translate these values into the box plot. And, oh, okay, I'll keep it on this page. Eek. All right, that's okay. So what we said earlier is, okay, this whisker seems to just go to the minimum. And that is true, right? Because it goes to 2.9, the most extreme value within the data set. So this one here is in fact 2.9. Looks like 2.9, and it is. Okay. We already knew what the median and the quartiles were, so I'll jot those down. Are they technically the median or the quartiles that R would have found? Yes, of course they are, but for our purposes, that's fine. 4.65 and 5.8. What I want to emphasize is that 8.5, if I drew 8.5, and maybe I should use different color here. 8.5 is the upper whisker or upper bound. Okay. But notice how there's nothing drawn at 8.5, right? So then it drops down to 7.3. Which is the next best thing within the bounds, which means that this one value, this outlier, is 9.4, which is what it looks like here. But notice how the bounds aren't part of your data, so they don't show up, but they do help you determine where the outliers are and where the whiskers would go to and that kind of thing. Okay. So here, let's just highlight this because that's important. Okay. It's not the upper bound. It's the next data point within the upper bound. Okay. Did I do everything? Different flow. All right. Good. So it's kind of the anatomy of a box plot. All right. And what we said was, okay, the box plot is just an alternative to a histogram. So what if we look at the histogram and the box plot side by side? And if I bring in the histogram here, there. and maybe I'll write a blurb here. The box plot and the histogram are both ways that we can visualize numerical data. The box plot and histogram are both ways we can visualize the distribution of numerical data. The distribution, and the distribution, remember, is the shape of numerical data. Okay, so let's look at them kind of side by side here. Whee. Wow, those don't look very similar, do they? Well, it helps if we turn this thing like this. Okay, and just because it's got the kind of the bounds so far off, I'm going to crop it, but they exist. But just so we can look at this a little closer. Yeah. Turning it sideways, I find, is helpful because now all of a sudden you're on the same scale on the x-axis, right? So that helps. But also, I like looking at histograms. They make it easy to visualize the distribution, right? So here, right away, I see that I have this kind of skewed to the right situation, right? That's not as easy to see here in the box plot, right? Because at least for me, when I see a short distance here, in my mind, I don't see, oh, well, that means that there's lots of data, right? But that's what it means, right? So when we see these short distances, well, it means that I was able to cover 25% of my data in a very short amount of time, right? Which means that the equivalent of that would be a high kind of post in our histogram, right? And so here, right, what we're seeing is from the minimum to the median, well, I know that that's 50% of my data, right? So it didn't take me very long to get through 50% of my data. And then it's going to take me longer to get through the rest of my data, right? And so here, and that's going to take some practice, right? But in general, a short distance means that there's lots of data, right? So when I look at this, right, that's where I'm getting this kind of right skew situation because I've got this peak here, right? If I draw my distribution underneath, it would look something like this, where the median is here, right? 50% of my data happened pretty quickly, and then it took me a little bit longer to reach the other 50%, or to kind of get through the other 50%, right? And so there's kind of pros and cons to using a histogram versus a box plot, okay? I would use a histogram because it is easier to visualize the actual shape, right? But if your job is to figure out if this is actually considered an outlier, right? We would have to say, if I was just looking at the histogram, I would say, oh, it looks like it might be a little bit skewed to the right. There's a potential outlier on the upper end, right, around 10. But I can't say that for sure until I've confirmed it, either by just doing the calculation, right, the 1.5 IQR rule, or by making a box plot where I can see, okay, yeah, it is considered an outlier, fine. Okay. So let's do pros and cons. All right. A histogram is easy to see the distribution, right? Makes it easier to see the distribution or the shape. Whereas a box plot, right, helps us identify outliers, right? Identifies outliers. So it kind of depends on what you need to do. And often you'll end up doing both, right? You look at the histogram. So usually I start with the histogram. And then if I suspect there's an outlier, I just go ahead and make a box plot, and then I kind of confirm it that way. Okay. Good. So what would a normal distribution look like in terms of a box plot? How would we identify a normal distribution? Well, a normal distribution is unimodal and symmetric, right? And so here, a normal distribution is unimodal, so one peak, right? And symmetric. About the center. So here we go. Not bad. It's always too short. That's okay, right? And so here in the center, that's where I'm gonna have the median, but also the mean, okay? Because the mean we know is pulled in the direction of outliers, but if it's symmetric, then things are even, right? And so not only does the center split our data in half, right? But it also is a good measure of center, so we can use the mean. So the median is the same as the mean, so I'll kind of draw them. I should say approximately equal. They're not necessarily the exact same, but oh boy, that approximately equal doesn't look very good, does it? Still no good. Anyways, squiggly equals approximately equal, but that means that just comparing the median and the mean tells us something about the distribution, right? And so even if we have a skewed distribution, then if we're able to compare the median and the mean, just those two values, we have some idea of what's going on. How? Well, we know the mean is always pulled in the direction of outliers, right? Whereas the median, we use it for non-normal data because it holds steady at the center of the distribution, right? And so if we have something that's skewed to the right, for example, then the median would hold steady here, let's say. And I'm just drawing pretend lines, but just so you can see it. And I'll exaggerate a little bit. I'll put the mean here. Right. Or the other skew. Right, if I have something like this, the median would be here. And the mean is always pulled in the direction of the tail. Right. The mean will always be pulled in the direction of the tail. Right, they're always being pulled in these directions. So we can compare just the numerical values of the mean and the median to have an initial understanding about the shape. And isn't that wild, right? This means we can compare the numerical values of the mean and the median, for an initial understanding of the distribution, which is the shape. For an initial understanding of the distribution. So what I want to do is I want to pull in that summary that we had or saw. Okay. That's part of the reason why, as part of the summary command, yes, it's the 5-number summary, but also it includes the mean, mostly so that we can look at that and also have a pretty good understanding of the distribution, right? So if I have these numbers, the mean is larger than the median, and it is kind of like a domino thing that you have to think about, right? But if the median or the mean is larger than the median, that means that the tail is on the upper end, right? And so just from looking at this, I would guess that my distribution might look something like this, right? Where I have my median is at 4.65 and my mean, I didn't really put a scale on here and that's okay, would be 5.108. So we will reach a point where you just look at those values and then all of a sudden you have a pretty good idea of what it might look like, right? And that's a really good skill. You're going to confirm with a plot, obviously, but it's a really good start. So that's why I always start with the summary command. What's the summary here of numerical data, right? Because then I can get a really good idea. I get the minimum, the maximum, I get the centers, how do they compare, right? I have a pretty good understanding of what's going on. Okay. So here, since the mean is, or maybe I'll even emphasize, the mean of 5.108 is larger than the median of 4.65, right? We suspect the distribution is skewed to the right, which was confirmed by our graphs, right? We suspect the distribution is skewed to the right. This was confirmed by our graphs. The last thing I want to mention, I forgot to say it earlier, but if we're looking at a box plot, what's a surefire way of knowing that it's normal? Well, that's going to be the symmetry, right? Symmetry around the center, so symmetry around the median. So a box plot shows a normal distribution if there is symmetry about the median. Okay. So that can look like, and I'll do them on the side here just for space reasons, can look something like this. Right here, these are roughly the same size. That's not always the case. We could have longer tails. We might have a huge amount of data here in the middle, and then have these longer tails, but they're roughly symmetric around the center, and that's what makes them normal distributions. Right, so here, these are symmetric. Oops. So these are both normal distributions. Okay. Ha. That's all, or all the basics of numerical summaries, visualizations, right? We've only talked about one variable. We'll talk about multiple variables, right? 2 variables later in the course, but for now, this is a really good kind of foundation. So on Thursday, we're going to talk about categorical data. There's not nearly as much to talk about. And like I said, even if you have a look at the assignment, I think you'll find that you kind of have the tools already to answer those questions. So check it out. And if you have any questions, let me know. Otherwise, I'll see you on Thursday. Stop this.